Mike. I'm the tech director over at Out of Dawn. I'm also the lead coder on Grimguard Tactics, which is what I'm going to use as the examples in my talk. I'm going to be going pretty quickly because there's quite a lot to get through. Also, I've had food poisoning for the last 2 days, so I'm going to do my very best to get through this without running off, but we'll see how it goes. Essentially, what we're going to talk about is some of the ways that I also encourage my coders to go about approaching designs so that you don't code yourself into a corner. So one of the things that I'm sure you've all heard if you're a coder is that you're supposed to build flexible and extendable systems and all this stuff, and for ages no one could ever tell me what this meant. You kind of figure that one out as you go along. But also, you're constantly told not to over-engineer things, not to make things too complicated. But interestingly, in my experience, these two things can kind of be at odds with each other. And it's very hard to know where the line between building flexible and extendable systems and not over-engineering goes. Also, there's always time pressures. So you've always got somebody telling you that things need to be done on time. So in my experience, it's actually very rare to find that over-engineering has actually caused any problems. I can literally count on my hand the number of times it's happened. When it does happen, it tends to happen quite spectacularly, in that everything will just collapse like a house of cards. But far more often is this, which is you wind up with building systems. You've been asked for a monkey with a stick and a nut, and you give the designer a monkey, a stick and a nut, and you can be like, hey, 100% success for me. The problem comes where, what if you don't want it to be a nut? What if the stick needs to be something else? What if the monkey needs to play baseball with the stick and the nut? My point being that systems being architected far too rigidly or far too literally has cost way more dev time and production time in my experience than over-engineering ever did. So, how can we guard against this? The first method is by extension. It's the simplest thing, and designers ask for what they need, okay? Extension is the gathering of gotcha requirements that aren't explicitly mentioned in the design, okay? Designers, like almost everybody else, are human, all right? They're not omniscient, okay? They don't know everything, and you shouldn't expect designers to know everything that they could possibly want, because they'll be focused in on what they're doing at the current moment, okay? And more importantly, you shouldn't really expect designers to know the ramifications of not asking for something, okay? That's what tech and code is there for, is to be like, hey, that thing you've asked for, a reasonable extension to that is this, and this is going to cause a lot of problems if you want to do it later on down the line. So it's easy if you have a look. Okay, as a designer, I want characters to move around on a square-based tile grid. It's the user story that we got. Seems simple enough, okay? So here's Out of Dawn. This is one of our debug views. It's our grid, reasonably standard. There's a lot of questions about this, okay? So when looking at that relatively simple design, okay, you have to ask yourself, what's a reasonable extension to what's been asked of me, okay? And then talk about it at length with the designers, with other coders, okay? Get other people's input into what you're thinking the design is asking for, okay? And ask yourself what's reasonable extensions might break what you're planning to do, okay? This is a really good one, which is like, okay, I've built this system, okay, and what things break my system? And are any of those things reasonable extensions? And the best thing to do is not just for yourself to answer whether or not it's reasonable, ask other people whether or not it's reasonable, because you probably won't think it was because you made the system in the first place. But somebody else might be like, oh yeah, that's a really obvious thing to want to do with your system, is to do X. And you go, oh my God, like X is going to break everything, okay? For Grimguard, so we had a look at this. One of the questions was diagonal movement. Okay, do you want diagonal movement? Because if we don't do it now, all right, It's going to be very hard to retrofit at some point in a live game. Okay? Non-square grids, not only like hexagonal grids, but you want rectangles, L-shapes, weird crosses. What do you want? Cost of walking through a tile. And actually its neighbor, which is waiting for the pathfinding, which are two very different things. Like it costs 2 steps to go through this tile, fine, but it's a poison tile, which means the waiting system should avoid it, okay? And the biggest one for this one, larger than 1 grid cell entities, okay? If I hadn't asked this question at the beginning, they would never have gone in the game. Okay, because, you know, you watch online, you've got grids, you see like A-star pathfinding or whatever. Nobody ever deals with this. No one ever says, oh, hey, what if we've got a 2x2 character or a 3x3 character? So those were the things that we asked, okay? So extensions are a fairly simple one. Sit down with your designers, sit down with other coders, talk about the design, talk about things that might break it, talk about things that might break it that are reasonable to assume that it will do, okay? Fairly simple. This one's my favorite one. This is by abstraction. So designers will ask for the end result, okay? So abstraction is the simplification of a complex set of requirements and can help to unify systems based on commonality, okay? So designers ask for what they want. They want a guy to cast a fireball. They want a skeleton to teleport to the other side of the screen. They want somebody to hit somebody else with a sword, okay? It's very literal. And they don't care actually how things get structured, okay? You don't have to structure your things like that, okay? And in fact, it's best not to focus in too much on the language of the design, okay? It's very easy to get caught up in, oh, they want, you know, they want swords and shields and they want attacking and they want abilities and they want movement and stuff like that. But abstraction can help actually simplify your code quite a lot, because if you find the commonalities, you can build a singular system to deal with all of these things. And in doing that, once it's working, you'll save time on things like QA. You'll only have one system to QA, one system to debug. You want to upskill people, you're only upskilling in one system. So if you can do this, this is great. Okay, so you'll also, interestingly enough, by doing this, you'll get a lot of extendability and a lot of flexibility in your systems, even though you weren't gunning for it. You'll get it just as a natural process of this. Okay, so if we have a look at another one, designer want our characters to attack within a range. Designer, I want our characters to be able to use abilities, and as a designer, I want our characters to have perks that affect their stats. Okay, just a few random things that came out of our designers. Okay, so if we watch a little video, hopefully, yeah, there we go. There's a minute of this, by the way. There's a bug in this guy. Just ignore it. Really cool. I didn't know it was going to turn out so well, this video. I literally just recorded one session, like one of our playthroughs on autoplay. Just happened to be that we got all the way down to one person. Just barely managed to win this. So, if we have a look at what we saw in there, this is a smattering of the things that you just saw happen in there. There's melee attacks, range attacks, there's multiple abilities going on. There was chain lightning, there's a fireball, there's earth spikes that are hazards that were cast onto the floor and somebody walked on them and they got damaged by them. There's burn over time, status effects, there was healing, there was teleporting, except like so many things going on, even the barrels exploding. All of that ran through one singular system, okay? And it has no idea about attacks or abilities or any of the rest of it, okay? So I was looking at this, I was like, well, let's ignore what designers are asking for and try to break it down to the essence of what they want to do. And then kind of thinking about attacks and abilities and the perks and the rest of it, and I just thought, well, actually they're just effects, right? It's almost like they're just you can think of an effect as just like a little bit of data. And that data needs to be generated by something, which is this, and then that data just needs to be handed over to something. And who you hand it over needs to know what to do with it. So we have like a receiver, and there can be many receivers. So, and initially I thought, oh, we could stop here. But we can't, because there's one more thing, which is this. There's a distributor. And the reason I came up with this was because by extension, I was chatting to the guys, and they were like, oh yeah, we're going to want these tile effects, right, where we like cast spikes down to the tile, but it's not the tile that's receiving the effect. The tile's just kind of like holding on to it, waiting to distribute it to somebody else that comes along later. But the tile's also not the thing that generated it. So I was like, oh, okay. We need a sort of third concept in here, in that you can generate a bit of data, you can give it over to end distributors, and those end distributors can then distribute that effect to end receivers, okay? So, I've just noticed that I can't like scroll up and down on my notes. So, yeah, the interesting thing with this was that I wound up thinking of like a manufacturing processing line, where you had factories that make stuff and then they give them over to like distribution centers, and then trucks come along and pick that stuff up and then take it to the people that need it. So I was a million miles away from thinking about games and abilities and fireballs and all the rest of it, okay? But we built something that does all of those things. Yeah, so the other thing to do with that is bookend your conversations with your designers. So ask them, what's the simplest thing that you want this to do? And they're like, oh, we want a guy to hit a guy with a sword. You're like, okay, tick, that's one end of the spectrum. What about the other end? What if you had carte blanche to do what you like? What's the craziest thing you can think of going on in this game? And they're like, oh, you know, we want chain lightning, but the chain lightning actually comes out as 3 forks of lightning, and then it hits guys, and then we want that to chain to other guys, and then we want those guys to have an effect, and they explode 2 turns later into more chain lightning. You're like, okay, sweet. And by getting those sort of bookending things, you can kind of find the middle ground and make sure that you cover those bases with your designs for your systems. I'm going to go into this a little bit more. So here is coder art. So what you just basically saw there was this guy, a little sorcerer dude, has just generated effect, okay? The user has basically clicked on a tile, dragged their ability over there and gone, hey, I want to do my ability. So what happens is we're basically missing 2 things. You've got this idea of generators, distributors, and receivers, which is all good. And there's 2 things missing. The first one was phases, right? So phases describe like what you're doing. Like, am I doing an ability? Did I move onto a tile? Did I start my turn? Did the battle start? Did I die? All of those things, okay? And the other one is criteria and ranges. So like ranges are who does it happen to? So we can see here that basically what happened was the user instigated this phase to run. It's the ability phase, okay? And it has a criteria that the ID of that phase must match, and the ID was the sorcerer. Okay, so we've got a list of all these generators. Okay, and they all have their own ID, and they're all registered, and they've registered their interest in abilities. Okay, the ability phase. So when the ability phase kicked off, we went down our list, and it was like, oh, my ID matches. Okay, and we're running an ID match, so I'm going to generate my ability. And then the generator is like, okay, so my range is the pick tile. So whatever one the user clicked on, that's where I'm going to generate my ability, okay? And what we got back was, that's ID tile 36. So we find the distributor on that tile and go, here tile, here is my ability. And the tile goes, thanks, I'm going to hold on to this until such time as I let go of it. So, here we go. Skeleton dude. Okay, so you can see here there's a bunch of like little tiles up there, so little spikes. That's what I generated. That's what I've stuck on that. This dude has just walked into that tile, okay? So if we have a look at that, the data that I gave to the tile, it got given to the distributor, it had this, and you'll recognize it, it's exactly the same as the way generators work. There's a phase, there's some criteria, there's an entity ID. In this one, it was tile enter. So every time a character moves around the board, we're firing off tile enter phases and tile exit phases. So in here, we've done tile enter, there's an ID match, the ID was tile 36, and it goes, okay, yep, tile 36. I've been entered, and I have an effect that I'm supposed to now distribute. So the tile goes, oh, okay, I'll distribute it. Who am I distributing it to? I'm distributing it to whoever walked into me. So it's like, cool, okay. Whoever walked into me is the skeleton. And so it just gives the skeleton the data, and the skeleton receives it. And by receiving it, basically there's a handler there, and it goes, all right, here's an effect, please handle that effect, and that effect goes off, finds his health component, and takes away 10 from his health component, okay? It's pretty, yeah, it's very simple, but had nothing to do with abilities and all the rest of it under the hood. It's just distributors, receivers, generators, bunch of data, some phases. So, and this one's a doozy. The third one is by separation, okay? Designers can ask for some really complicated stuff, okay? And again, you can't necessarily expect them to understand the complexity of what they're asking for, okay? And separation is the dividing of functionality from a single system into n separate but tightly coupled systems. When I was writing this, my missus looked at that and went, why on earth would you take one system, split it into two systems, just to couple them back up again, when you had a perfectly good system in the first place? And she's perfectly right. The answer is that you would almost never do this, okay? It requires the most engineering out of any systems that you're going to go, and there's always going to, you're always going to make it more complicated, and there's always going to be an ongoing cost of maintaining your separated systems, because anytime you make a change to one system, you're going to have to go and reflect that change in the coupled system, etc., etc. So, why on earth would you do it? The reason that you do it is because sometimes it's actually the cleanest way to get to what design want, okay? This actually happened to me, okay? This was, as a designer, I'd like to simulate an encounter a few hundred times and see the win-loss ratio, okay? Back to extension and designers not knowing what they ask for seems perfectly reasonable, doesn't it? You're like, oh yeah, we're just going to run this battle 100 times, let me know what the win-loss ratio is. Okay, yeah, cool. Let's just have a look at that, okay? That's 1.5 minutes per room, judging by the speed that the autoplay goes, okay? There's 3 rooms per encounter. I want to do that 100 times. That's 7.5 hours of gameplay to get them the results of 100 battles on one encounter. We have hundreds and hundreds of encounters, okay? The vast majority of that time is taken up by the visuals. And it's like watching the guys run around, playing the particle effects and all the rest of it. And by the majority, I mean 99% of the time is taken up watching the visuals, okay? So if you've built and launched a singular system that does all of your logic and your visuals and everything else, you're in the corner at this point, okay? You're very limited in your options, okay? There's a lot of things that you can do, is like you can try speeding up the FPS. Unity have this really cool thing online where they'll run your game at like 1,000 FPS. But you start to get into problems with things like missed animation events and soft locking and various other bits and pieces, because the visuals just can't keep up and you're relying on a lot of timing that's going on inside your animations or your VFX systems and the rest of it, and you'll probably find that it doesn't work very well. You'll also find that probably what you'll do is put if simulation throughout your code, okay? And we do have an if simulation, but we have one of them. So the way that we did this is I broke our system into two, the combat simulator and the combat visualizer. And in essence, there's like this command system that sits between the two of them, okay? Anyone familiar with network coding might see some parallels going on here because it is very, very similar. So basically what you've got is you've got this idea that you have a bunch of commands on one side, like move path, run an attack anim, show some text, play their death anims, and you have visual handlers for those things. And at the simplest form, we basically go down, like we want to move path, we find the handler for it, we wait for the visual handler to say, I'm finished, and we move on to the next command, give it over to a visualizer, we wait for it to finish, etc., etc. So, hey, what happened there? So for the eagle-eyed of you, you would see that a little green blob moved from here to here, okay? What we've just done is we've simulated a move of the Blade Master from its origin square to that in front of the enemy. We've simulated attack by the Blade Master against that skeleton. That skeleton is actually dead at this point, even though he's still standing there, looking as healthy as skeletons do. He's still alive. Yeah, he's dead. Okay? And a bunch of commands have been added to the command system. And there's a move path to be executed on the Blade Master. There's a play and attack animation, also to be executed on the Blade Master. There's a wait for the attack impact, because art being art, they want the flinch to happen just at the moment that the sword arrives on the skeleton. We've got play a death animation that's supposed to happen on the skeleton. And there are a few others, like playing hit point damage and showing text and the rest of it. Okay. So, there you go. So, it's just done exactly what those commands said, right? And one of the best things about this system is that while that was happening, you may notice this little thing's moved. So while your visuals are playing out, the simulation has actually done the next part of the game. It's been caching all of the board state because it doesn't care about the visuals. It already knows what the board state is. So while the visuals are catching up with it, it's free to do all this heavy lifting while you're watching it. And we do so much heavy lifting and we spread it out over multiple frames while the user's just watching the game play out, and they are none the wiser. So that actually, interestingly, wasn't what I was going for in the first place, but it happened to be a really nice after effect, again with this like extendability, flexibility of the system. I realized that once we built this, it meant that we had so much free time to kind of like do really heavy computational lifting while the user's happily watching what the game's doing for them. So how is it actually built? The way that it's actually built is pretty close to this. It's more complicated than that, but the simplification of it. So Combat Simulator generates these commands. The commands, when we call it flushing, so basically at the end of an action we flush the command buffer. Each command will say, hey, visualizer, is there a visualizer, is there a handler for this command? If there is, I'd like I'd like the handler to do its job and just let me know when it's finished. And when it's finished, I'll move on to the next command. So, and it literally just goes down this list like that, on and on and on. Okay? So, how did we actually get what we wanted? In this case, C# interfaces are your friend. Okay, so Combat Visualizer is responsible for all of the loading and handling of visual stuff. So that's where the big separation comes. And you have to be really strict, okay? You keep an eye on your simulator code. Anything that happens in there is not allowed to reference anything to do with visuals at all. If it does, it has to do it through the combat visualizer, okay? There's an actual combat visualizer, and because we've done interfaces, there's a stub one, and the stub one has no functionality in it. All command visual handlers are registered via the combat visualizer, and it's also how you get at the handlers, okay? So when a command runs, just like we said, it asks the visual system, hey, is there a handler for this? If there is, I'm going to wait for it to finish its work, okay? If there's no handler, the simulation command system is sensible enough just to be like, oh, all right, don't worry about it. I'll move on to the next command, and I'll ask for a handler for that. So all we need to do is make sure that our stub, when we're simulating, never gives back a handler. Okay? It's that simple. So we have one place in code where we're like, if simulation, instantiate our stub visualizer. If not, do the full visualizer. And after that, everything just works. So let's watch the, not the same, but very similar one without that. And there we go. So that was the game simulating itself, very similar length to that one. That one takes roughly a second per room, and that's without me even really trying to speed it up. 3 encounters per room, 100 encounters, 5 minutes. We've gone from 7.5 hours to 5 minutes, which is a much more reasonable thing. We can run these overnight, like we do it all the time. We run loads of them, they spit out like win-loss ratios for your stuff. Okay, so quick rack up. By extension, easy if you get in early, okay? Have a good idea of what might break your code, okay? That's almost like rule 101 for that one, is when you're building something, think to yourself what will break it, and then think to yourself, is that a reasonable extension of what I'm building? And God, just talk to people, okay? You will save yourself so much trouble if you just talk to the team before you write any code. Abstraction can be very difficult to wrap your head around, okay? My version of abstraction with the generators and the distributors and the receivers is not the same as somebody else's, okay? The idea is the thought process that goes into it and the finding of similarities and commonalities and trying to break it, trying to ignore the literal request from the designer. It takes a lot of practice. Should always be a simplification of the design, okay? If you can't explain how it works to someone, then it doesn't work, and you need to start again. It's no good taking something and being like, oh yeah, you've asked for skeletons to hit this. I've got this mind-boggling abstraction of a system designed for it that no one will ever understand, okay? It has to be a simplification, okay? Relies largely on commonality, and it always adds flexibility and extendability to your system by default, okay? It's really good. And separation should be avoided at almost all costs, okay, unless it is absolutely justified, okay? Always going to have complexity, it's always going to have maintenance, okay, but it can lead to some really, really good benefits, okay? So thank you. That was Grimguard and Out of Dawn. And also, if you've got mobile games Unity experience, I'm hiring. So you can get me at mike.page@outofdawn.com. Thank you. Oh, I'll have a check on the app to see if there are any questions. We've got like 2 minutes, but I talk very quickly apparently, so. Does anyone have any questions?
I do.
Oh, sorry, guy behind you was quicker.
When do you know when to stop abstracting?
When do you know when to stop abstracting? So I always give myself a deadline. I'll be like, and I also always build it into production. So I will always say, hey, look, for these 3 days this week, I'm going to be brainstorming the living daylights, and I'm up and I have whiteboards and I have pens and I have people in my office and we scribble out ideas, but I give myself a time. You just have to give yourself a time limit, okay? Because you can wind up going round and round and round the houses with this. And also early on, it's better to get an idea, run with it, see where the problems were, learn from it, start again for the next thing, run with it, see where the problems are, and you'll learn to just get better and better and better. So.
I'm just curious about when in the project life cycle you decided to create that separation of the visual.
Not early enough. Yeah, is the answer to that question. Not early enough because we didn't.
Hard to pitch to the team to make.
No, I am the tech director, so yeah. I mean, it does come with certain privileges, and privileges is no. I don't find it very hard to pitch things to the team. It was a lot of work though, and we weren't focused enough on how we were going to like get the metrics for the game that we needed. And once you've sat and you've watched like the one designer play the game hundreds of times, balancing it on his own, you realize there's a problem there. And that is basically when I was like, okay, we need to go back and separate this out. Luckily, I was kind of halfway there anyway, with a lot of the way that we built it, so pulling it apart wasn't too bad. Oh, one more, I'll do it very quickly.
Maybe a bit of a superficial question, but when you're making a really abstract system, how do you come up with a good name for it? So you don't want to be overly descriptive, but you don't want to be overly prescriptive either.
Yeah, that's a good question. I honestly tried to think in real world terms. So like that one, I just wound up thinking about manufacturing. Because once I thought about like we need to make something, then I just started thinking about what in the real world, because real world is really easy to get across to everybody else. So what in the real world kind of matches what I'm doing here? So then I wound up with like, oh yeah, you're making something. I almost had makers, distributors, and like customers and stuff like that. I was like, I can't call it customers and I can't call it makers. That sounds terrible. So you go around a little bit, but yeah, I always try to go for something that's real world and understandable so that it's easy to explain to people how it works. Because again, if you can't do that, then it's not a good abstraction. And now we've got to stop. Cool, but yeah, feel free to grab me.